Hello, Prepress Professionals. Let's take a close look at color. Here is a recently printed piece. It's in two colors. We ran a Pantone and a black. You can see that the black type nicely overprints the Pantone, and the Pantone then traps into the black strokes that make the boxes. This piece here is a little bit more challenging. It's in full color. Of course, we use cyan, yellow, magenta, black to reproduce this piece. It seems lately I've been getting a lot of questions from my customers. What's the best color mode for me to work in if I'm doing full color? So I've decided to take this episode to explore a good answer to that question. We'll be dividing this into three parts: color mode, color space, and color values. Let's talk about color mode first. If I'm interested in an individual file, I'll open that up in Photoshop and do an image mode, and there I can see its color mode, RGB. Likewise, look at the tab. There it is. Here's another color image, image mode. It's in CMYK. It's ready to be printed. Just by looking at these two images, they're both in color, but they're in two different color modes. Now, let's move over to the third image. This is in grayscale, image mode grayscale. Typically it will print in black ink. Doesn't have to, but it has one channel of information. Now, usually what we're doing is we're inside of Acrobat Professional and we're looking at entire pages. Here I have those three images in three separate pages. How do we know the color mode? Well, we use Output Preview. Here in the preview, it normally says separations. Let's go down to Object Inspector. Important, you have to click on the image. There we see RGB. Let's move down to page 2 and do the same thing. Click on the image, and it will tell us it's in CMYK. Now let's move down to page 3. Same thing. Click on the image, and it will tell us that's in grayscale mode. So you have to use Output Preview, and you have to use the Object Inspector. That's the only thing that will tell you the truth. To see the color values, let's open those images back again here in Photoshop. I'm going to use my eyedropper, right-click. Instead of a point sample, I'm going to use an 11 by 11. I'm also going to bring up the info window. Notice as I move around, the RGB values, they change. At each spot, this is where the camera recorded its sensors right here: red 194, green 127, blue at 81. As I move around, I see those numbers change. That tells me there's detail in this picture. Let's go to the CMYK. As I move around, you'll see different percentages for cyan, magenta, yellow, and black. The dark areas use a lot of ink. The light areas use very little ink. Let's go to the grayscale. As I move around, let's go to a dark area. The number is high, and as I go to a very light area, there the number is very low. It's tempting to think of these values, the RGB values here, as color values, but they're really not. Let's go to our panel options, and for the second color readout, let's choose Lab instead of RGB. What's the difference between these? The RGB values, those are device values. That's what my camera recorded at every spot. The lab values are the color that will be reproduced in my mind when I see that color on the screen. Likewise, when I go to CMYK, I'm moving around. I'm seeing different device values in cyan, magenta, yellow, and black. But I'm also seeing different lab values. Lab is a way to describe the color event that happens inside your head. Same thing here in gray. As I move around, I'll see the gray value change, but I'm also seeing the lab value. Lab works in opposition. When L is low, it is dark. When L is high, it is very light. How does this conversion between device values and lab values happen? For that, we now must start talking about color spaces. For that to happen, let's take a little trip outside and take a few pictures. Let's start with a picture of the rocks. They're fairly gray. I'm going to move this into a piece of software called Color Think. Here I can take 1,200 patches, measure them all at once, and do something interesting. I'm going to plot all those points in a three-dimensional space. Now those rocks are mostly gray, and you can see them very close to the center here. That means they're low in saturation. They're not perfectly gray, maybe slightly yellow, maybe slightly orange. Let's take something that's very vibrant orange, this flower, and do the same thing. We're going to take 1,200 patches, measure them, and plot them in the same fashion. Here I'm expecting to see a very saturated orange color. And sure enough, I see that here. And I got a little bit of the green background, just a little bit. Notice how saturated and how bright those orange colors are. Now to the purple flower. Same thing, 1,200 patches, and we've got the purples, a little bit of the green background, and also there's some yellow in there too as well. Okay, this was the two yellow flowers. Here we have the deep green grass and weeds. Here is the blue sky. Look at that, it's just a sliver of blue and a little bit of the white clouds. Now that black tree actually was kind of green. Now let's do something interesting. Let's put them all together. When we do this, we notice something interesting is taking place. And that is, all those color samples are taking a shape. That shape is a color space. A color space is a three-dimensional thing. It has a size, it has a shape. And what that means is the digital camera that I was using, no matter what color that I took a picture of, that color will always appear inside of this shape. What I want to do is show you a synthetic picture. This is data that is mathematically derived, not a picture of a natural object. And in this picture, you'll be able to see all the color possibilities. And here you'll be able to distinctly see its shape. Now, I don't normally look at this as individual points. My preference is to display it as this solid. This is the most common way to view a color space. Now, every device has a color space. I want to show you my monitor that I do video editing on here, and then also my laptop. Color space of an actual device, and then here, the smaller being my laptop. Both are RGB, but they have different color spaces. Now let's take a look at my camera here versus a printer. The camera has a large space. Printers typically have much smaller color spaces. Camera, printer. Now my printer can use a variety of different kinds of paper. This is an uncoated paper, but when I put in a glossy stock, the color space is a little bit different. Look at the bottom. This is uncoated. This is coated. I can print darker colors with the coated stock. Color spaces tend to get very, very specific. In fact, it tells us a lot about the device, be it a monitor, a scanner, or a printer. By way of an analogy, this is kind of silly, I do admit. I like to think of color mode as being so general that it's like talking about a person and all you know is male or female, but with color space. Now you know who they are, their name, their appearance. In fact, it feels like they're standing right there in front of you. What you just saw were color spaces of real devices, a real monitor, a real printer. But there's a whole nother type of color spaces, and these are idealized. I think of them as maybe virtual spaces or fake color spaces. I call them that because they don't really represent a real device that you'll find. These play a particular role because that idealized state represents something that we really like. For example, gray balance. My monitor, after I've prepared it for use, I've gone through a process of calibrating and profiling my monitor to build that color space, is not perfectly gray balanced. What that means is that equal amounts of the red, green, and blue signal, let's say 128, 128, 128, is not perfectly gray. In fact, it's nice if it's close, but it doesn't have to be exact. The idealized color spaces have perfect gray balance throughout 0 to 255. Another feature that they have is that they are perceptually uniform. What this means is that a particular change of, let's take an example here, the midtone in blue will give us a result that we expect. Similar, if I do the same amount of the green channel, I'm going to get a result that I expect. This is perceptual uniformity. Those are two of the features that idealized color spaces, and you've seen these, as editing spaces inside of Photoshop or InDesign, Adobe RGB, Apple RGB, sRGB, so on and so forth. In fact, there are hundreds of them. There are even idealized color spaces for printers. We use them for standards. You'll see them as faux gras over in Europe, for example, or grackle over here in the United States. That's what I use at my job. There's a family of 6 of them. We call them CRPCs, Characterized Reference Printing Conditions. Oh my, what a name. And they represent idealized or perfect printing. And our goal is to get as close as possible to that. At the beginning of the video, we posed the question, what's the best color mode to work in if I am delivering full color work to my print service provider? And we've discussed RGB and CMYK. For those of you looking for the quick answer, I would say RGB. Images are captured in RGB, scanners capture in RGB, and let's just keep it that way and deliver that file to the print service provider and let them, with their professional workflow software, convert it to CMYK, and that's an easy process for them to do. For those of you who are looking for perhaps a little bit deeper answer, I think it's important for important work to be done on a well-calibrated and profiled monitor in a good working environment with few distractions and where the monitor is the brightest thing in the room. If you have any control over the photography, it's important that there you set a white point and capture in camera raw, and on that well-calibrated monitor you can make real good color judgments in the color raw before they are opened, for example, in Photoshop, where further work would happen. One thing that you can do is ask for an appropriate output profile. For example, when a job is going to be printed, it's entirely appropriate to ask for the profile used for that device. It's either that device that has been profiled or the standard that they're trying to achieve. And what I recommend they're doing is previewing. You can take an image that has been captured in RGB and easily preview it using Control-Y or Command-Y on a Macintosh to see what color changes will be made. Because typically output color spaces are smaller and conversions will happen. We call that gamut compression, and you can preview that on the screen. However, when you deliver, keep those files in their original RGB color mode and whatever color space that you're using to do your editing in. So, as a summary, files that start off their life in RGB, well, keep them that way. If you have any legacy files, files that have been hanging around for a long time, they've long ago been converted to CMYK, well, keep them that way. And it's a good thing for our customers to insist on wanting to see accurate proofs. That's a good thing to do because often those legacy files are in either an unknown color space or a color space of a printer that was used long ago. And there may be some changes of color printed on a perhaps more modern device, especially one that is stringently following standards.